Hey, Journey team. Today we are going to be finishing up the first day of our week that ends our wave unit. We only have a couple of vocabulary words. I'm so proud of you. You guys have come a long way in this entire waves unit, and we are wrapping it up in the next few days. So I'm going to get to the point. I can use wave properties of light to explain reflection, refraction, and the color spectrum. As always, I've gone through and I've entered the answers for this Pear Deck so that you have them and you can plug them into your notes so that you can study this week. I grabbed a lot of information, not only from the Quizlet terms that we've been studying, but going into that PhET simulations, phet.colorado.edu. You're welcome to go in and try these on your own, but that's not an expectation, but it is a lot of fun when you get to play with these waves and see for yourself what's happening. Right now, we're going to be moving into what is reflection. I know you know that reflection is when you look into a mirror and you see yourself on the other side. But let's talk about what if you don't look directly into a mirror in front of it, but you're looking in sideways at a mirror and you're seeing the rest of the room instead. What is actually happening in this situation? Let's look at the rules for reflection. So, reflection is showing us in this PhET Colorado simulator is showing a laser that is aiming down into a surface. Say this is water, okay? Now we know that this laser is going to go down and shine through the water, and we're going to see this refraction line here. But that laser is also going to reflect off the water. And if someone's standing on the other side of this water, they're going to notice that the laser bounces off the water as well. What I want to show you though is that the angle that the light goes in is right now at say 36-degree angle. It's going out at that exact same angle right there. And so as I change where this is going in, take a look. I'm changing this to 70, 80, 85, and it always matches, and it's 85 out here. I like to relate that to a bounce pass for sports and tennis when you're bouncing something off a surface and you send it at those angles and you expect the ball to go out that other side. Now that's different because that's matter and this is energy, which means this is a cleaner description of reflection in that it's going to always be exactly the same. It's not going to be affected by gravity whatsoever. It's going to stay the same angle in and out. I am ignoring this line down here for refraction. We've already learned about refraction. So I'm paying attention to the angle it goes in and the angle that it comes out. So in our presentation, go ahead and put in the definition for bouncing back of a wave when it meets a surface or boundary, and then put in your flashlight, angle it out the exact same way, do your best with it, but then show this marking to mean that that is the same angle. You can even put in a number and say, okay, this is 45, so then this has to be 45 degrees too. Let's go to our next slide once my tools get out of the way there. Sometimes a wave, instead of bouncing off, the surface is really bumpy, or it has holes in it, or it's a certain color of shirt or has different properties. And so the light cannot bounce off or reflect. The opposite of bouncing off, the opposite of reflect is to absorb. When you send white light into a surface and all of the white light bounces off, you would see a white color coming away from it. But what if the material, say it's a clothing, a sweatshirt or something, a jacket that has other properties and white light goes into it, but our eyes are seeing black? That means that the white light is getting absorbed into that coat and there's no light that's shining back to us. So that would be a black color if that's happening. So consider this summer if you are trying to stay warm or if you are trying to stay cool. When wearing the color black material, you are going to be collecting and absorbing all of sun's light, and that is actually going to keep you warm because you are receiving that radiation and you are keeping it. Whereas if you wear something very light colored or white, it's going to be bouncing most of that radiation off, and you're going to be less likely to feel that radiation and that heat coming in. And that might be a benefit that direction. So you've got to kind of just consider that as you are dressing for these warm summer days that are coming up. Another way to talk about reflection is sound. When you send sound into a very smooth, flat surface, it's going to bounce off, and that is called an echo. So, draw your best echo, explain what an echo is as a reflection only as a sound wave instead of a light wave. Interference is when we talk about what if there isn't just one set of waves? What if you have waves coming from two different places and they are meeting together at the same place? Do they block each other? They don't. They actually go right through one another to the other side. So if you're getting pulled by a boat this summer on a lake, and there are a lot of different boats, the lake is busy, or your own boat itself is creating a lot of different waves. When those waves meet one another, they're going to add up to a very large crest or a deep trough. And sometimes they cancel each other out, and you get nothing. And so you kind of take a gamble on whether or not you're going to receive the crest or trough, or if they all smooth out because they all meet the same point. That's called interference. When looking at interference, we're going to be um, watching waves come from two different locations here. So I've turned the faucet on here, and you can see those waves moving out into all directions from it. But when I turn the second faucet on, it also moves out in every direction from where it lands. And you can still see that circle move out from both of those drops of water because they're moving through each other. They don't get blocked, they don't reflect off, but instead they move through. There's a lot of different ways that you can look at this. You can turn them into sound particles and see how interference looks like as sound. You can see it as waves. You can see it as both, and then it's really getting crazy. You can ask for a line graph to show you how great the amplitude gets when those are happening. If you've ever been in a car and you've rolled down the windows at exactly the same points, your ears start feeling vibrations in them. That's a lot of interference because you're getting those compressions happening at the same time or at opposite times. And so you have to kind of find the right level of which to roll down each of those two windows so that you're not receiving those compressions at a high level for it. So, just some personal experiences to relate to these waves and interference and to add into your slideshow. So when we have this and you enter that, that's it for today. I wanted to keep it short. So study these and go into Quizlet. You will be having an assessment based on vocabulary words. And maybe we'll get some Quizlet live in today or this week too. Have a wonderful day. We'll talk to you later, you guys.